Welcome, ladies and gentlemen, to the second video of Chapter 2, which is Analyze Conditional Statements. We have 3 objectives for today's video. We are going to write a statement in if-then form. Then we are going to take that statement and write the converse, inverse, and contrapositive. The last thing we're going to talk about is something called a biconditional statement. So today's video is mostly going to be no numbers. It's going to be just a lot of writing. We should probably start with writing a statement in if-then form. A statement in if-then form is called a conditional statement. So for conditional statement, we're just going to write a statement in if-then form. And then here's an example. If it is raining, then there are clouds in the sky. That if it is raining part, the if part, is called the hypothesis. The second part, the then there are clouds in the sky, that's called the conclusion. So the first thing that you're going to be doing is you're going to be taking a statement and writing it in if-then form. So looking at our first example, right here it says all cows moo. So we need to write this in if-then form. So if-then form would be if an animal is a cow, then it moos. So the if an animal is a cow part, that's the hypothesis. The then it moos part is the conclusion. Okay, so there's another example for you to try. 2 angles are supplementary if they are a linear pair. So it gives you a clue right here, if they are a linear pair. So this one will go, if 2 angles form a linear pair, then they are supplementary. Okay, so the notation for this if-then form, it's called P implies Q. So this means if P, then Q. So if P, then Q. So in the all cows moo example, if an animal is a cow, that would be our P. Then it moos, that would be a Q. So P is just the if part, Q is the then part. Okay, so our next term is a negation, and that just means the denial of a statement. So for the example, I like cows, the negation would be I do not like cows. So I'm just negating my original statement. Now the notation for a negation is tilde P. So the tilde is the negation part. Okay, so this shouldn't be too bad so far. So that was the first objective, is taking a statement and writing it in if-then form. Now we're going to take a conditional statement and we're going to write the converse, inverse, and contrapositive. So remember that the original statement is P implies Q. So the converse goes Q implies P. So this just means that you reverse the statement. So you write the second part first. The inverse is I negate both P and Q. So I'm going to negate P and Q. And then the contrapositive is the converse and the inverse put together. So I'm going to reverse the direction and I'm going to negate. So contrapositive is negate and reverse. Okay, so I know this is a lot of information, so we're just going to do an example together so we can see exactly how this works. Okay, so example number 2. The statement is guitar players are musicians. You are going to write each of the forms and then determine whether the statement is true or false. So in if-then form, we would write, if a person plays guitar, then he or she is a musician. Okay, that would be if-then form. This would be a true statement. If you play guitar, you're a musician. That's true. Okay, now remember that if-then is P goes to Q. Converse is Q goes to P. So I'm going to write it in the reverse order. If a person is a musician, then he or she plays the guitar. Okay, this is false. So this statement is false. Just because you're a musician doesn't mean that you necessarily play the guitar. You could play the violin, the cello, the trumpet, piano. There's a whole bunch of other options besides the guitar. Okay, now on to inverse. So inverse means, taking my if-then, I'm going to negate both P and then I'm going to negate Q. So in this case, we would say, if a person does not play the guitar, then he or she is not a musician. Hopefully you can tell that this is false. So I could not play the guitar, but I could play the piano. Then I would still be a musician even though I don't play the guitar. Okay, last one is contrapositive. So contrapositive, I'm going to flip P and Q, and I'm going to negate. So if a person is not a musician, okay, so that's flipping and negating, then he or she does not play the guitar. Okay, so if I'm not a musician, then I do not play the guitar. That's going to be true. Because if I did play the guitar, I would be considered a musician. So this is not too bad. You just have to memorize what each term means. So converse means I'm going to flip. Inverse means I'm going to negate. Contrapositive means I'm going to flip and I'm going to negate. So let's flip to the next page. Okay, so example number 3 is the example that you're going to do. I would like you to pause the video right now and try example 3 on your own, please. It would be a good idea to write the P's and Q's underneath like I did on the previous page. So if-then form is P goes to Q. Converse is Q goes to P, etc. This should take you at least 3 or 4 minutes. So pause the video, do all 4, come back when you are finished, please. Okay, let's see how we did. Equilateral polygons are regular. So the if-then form would be, if a polygon is equilateral, then it is regular. For the converse, you should have flipped the order. So if a polygon is regular, then it is equilateral. Okay, so inverse, you should have negated both P and Q. So if a polygon is not equilateral, then it is not regular. And then for contrapositive, you should have flipped and negated. So if a polygon is not regular, then it is not equilateral. Okay, so now we have to decide whether each statement is true or false. For the first one, if a polygon is equilateral, then it is regular. That should have been false. A polygon has to both be equilateral and equiangular in order to be regular. Converse, if a polygon is regular, then it is equilateral. That's true. Regular means the polygon is both equilateral and equiangular. Inverse, if a polygon is not equilateral, then it is not regular. That's true. If a polygon is not equilateral, it can't be regular. A polygon has to be both equilateral and equiangular in order to be regular. Last one, if a polygon is not regular, then it is not equilateral. That's false. So a polygon is not regular if it's not equiangular, but it still could be equilateral. Okay, so hopefully that one went well for you. Again, you just have to memorize the different forms. That's the easiest way to do it. There's no trick. You just have to remember them. So one important theorem we need to know, if the conditional is true, then the contrapositive is true. There's no such relationship with the converse and the inverse. So the contrapositive and the conditional are always going to match truths. So in example 3, the conditional or the if-then and the contrapositive were both false. In example 2, they were both true. There's no relationship with the converse or the inverse. Just because the conditional is true, the converse could be true, it could be false, we don't know. Same thing with the inverse. Okay, got one more idea, and that's this idea of a biconditional statement. So a biconditional statement is a statement when the conditional and the converse are true. It's written as an if and only if statement. So looking at the example, it says, if two lines intersect to form a right angle, then they are perpendicular lines. Okay, so converse, remember, means to flip. So this is my P to Q statement. My converse is going to be Q to P. So my converse would be if two lines are perpendicular, then they form a right angle. Okay, so let's check our truths. In the if-then, if two lines intersect to form a right angle, then they're perpendicular. Yes, that's true. The converse, if two lines are perpendicular, they form a right angle. That's also true. Okay, my conditional and my converse are true, so I can write this statement as a biconditional. The biconditional would be two lines form a right angle. So that would be my hypothesis part. If and only if. Okay, so this is what makes it biconditional. They are perpendicular lines. So that's the conclusion part. So what you're going to notice is that a biconditional has no if or then. It only has the if and only if. So it doesn't have a beginning if. It has an if in the middle. So the biconditional, two lines form a right angle, if and only if they are perpendicular. Okay, one quick note that I want you to write down before we go on to our next example. Biconditional statements are used for definitions. So in the classwork, you're going to have a question or a few questions asking you, is this a good or a bad definition? And it all depends on if the definition can be written as a biconditional. If you can write a statement as a biconditional, then it's a good definition. If not, then not a good definition. So we'll look at what I mean in example 4. It says write as a biconditional statement. The definition is an angle with a measure between 90 and 180 is called obtuse. So the if-then form would be if an angle measures between 90 degrees and 180 degrees, then it is obtuse. Okay, the converse, so just flip it. If an angle is obtuse, then it measures between 90 degrees and 180 degrees. Before we even write the biconditional, I want to make sure that we can. You can write a biconditional statement when the if-then, the conditional, and the converse are true. So looking at our if-then statement, if an angle measures between 90 and 180, then it is obtuse. That's true. If an angle is obtuse, it measures between 90 and 180. That's true. Okay, true for the conditional and for the converse, then I can write it a biconditional. So you're going to notice that when you go from the if-then or the converse to the biconditional, you are going to have to change the wording a tiny bit so that it makes sense. I didn't mention that earlier in the video. But going from if-then to converse and then if-then to biconditional, the wording is going to change. So make sure you read the sentence back to yourself to make sure that it makes sense. So let's do the biconditional. An angle measures between 90 degrees and 180 degrees if and only if it is obtuse. So I told you that biconditional statements are used for definitions. In this case, this would be the definition of an obtuse angle. So an angle measures between 90 and 180 if and only if it is obtuse. So again, the if-then, the conditional is true, the converse is true, then the biconditional is going to be true, and it's going to be a definition. Okay, so example 5 is the one that you're going to do. This time I give you the biconditional, you're going to write the conditional and the converse. So right now, pause the video and try this one on your own, please. Good luck. Okay, let's see how we did. Two segments are congruent if and only if they have the same measure. The conditional, the if-then form, is going to be if two segments are congruent, then they have the same measure. The converse is just going to be the reverse direction. If two segments have the same measure, then they are congruent. Okay, and this would be the definition of congruent. So the conditional is true, the converse is true, that's how we get the biconditional. Biconditional is used for definitions. So remember in the classwork when it says, is this a good definition? You need to look, is the conditional true, is the converse true? Okay, so that is all for the second example, or for the second section. Our objectives, we talked about the conditional, the if-then form. We talked about the converse, inverse, and contrapositive. And we also wrote biconditional statements or biconditional definitions. So here's your last example that you are to do. You're going to write the converse of the statement, and then if it's possible, you're going to write the biconditional. If it's not possible, please tell me why. When you come to class tomorrow, I'm going to check to make sure that you have this last example completed. Good luck!